Hello and welcome to this video brought to you by Smart Exam Resources. In today's video, I shall explain to you the concept of purity. Now, I am using my notes for explaining the concept, and let me tell you something, these notes are relevant to the latest syllabus. Secondly, they are based on extensive research of the past papers, so everything mentioned in the notes is totally agreeing with the marking scheme. Your teacher cannot say that this answer does not agree with the marking scheme. That statement you'll never get to hear if you're using our notes. Okay, with that assurance, let me share a good news rather. And the good news is that these notes are available free of cost on smartexamresources.com. That's our website, and usually the website is into selling a large number of resources, but here I thought let me make a small contribution from my side towards your learning, because there have been many children who have been requesting continuously because they wanted us to provide them with a large number of study material, study resources, and I thought let me contribute in my own little way. So these notes along with few videos, or rather all the videos, all the IGCSE videos that I have put on the site, all the videos along with all my study notes for 0620 chemistry IGCSE are available free of cost on our website smartexamresources.com. Now with that, let me begin the concept of purity. So the first thing is pure substances have sharp melting and boiling points. So what do I mean by the word sharp? Well, sharp means exact. So if I say that something has got a sharp boiling point, what I mean is that particular substance will only boil off at that one particular temperature. So for example, let me talk about the boiling point of water, and you know the boiling point of water is 100 degrees Celsius. But now after learning the concept of purity, learn to say that the boiling point of pure water is 100 degrees Celsius. So if the water is really pure, if you put a thermometer into the boiling water, it will only show 100 degrees Celsius and no other temperature. Similarly, if you talk about the sharp melting point, now again sharp means a fixed, and melting point, you know, when the solid changes into a liquid, that's at the melting point. So again, if I talk about the pure ice, so pure ice will have a melting point of 0 degrees Celsius. So if your crushed ice, if you have crushed ice in a bowl and if you leave it in a room and if you insert a thermometer into it, the temperature will stay constant at 0 degrees Celsius till all the ice has melted. So if that's going to happen, meaning the melting point is sharp, and you can with confidence say that yes, you have in your bowl pure ice. Fine. So now what happens if the substance is not pure? So here we have already covered about the pure substances, the characteristics of a pure substance. Effect of impurities is the second part here. So effect of impurities over here. Due to the presence of impurities, the melting and the boiling points will not be sharp anymore. So the melting and the boiling points will now not be sharp. So if you talk about pure water, it will not stay 100 degrees Celsius, and if you talk about the pure ice, the melting point will not be now 0 degrees Celsius. So then what happens to the melting and the boiling points? The boiling point will be further increased due to the presence of impurities. Okay, so in case you had a graph like this, wherein suppose this was 100 degrees Celsius and this was 0 degrees Celsius, and this could have been some -5. Maybe my scale started on the y-axis on -5. So this can be my temperature and this can be my time in seconds. So that means I'll just mark the sections of the state change. So this means that, sorry for that, okay, this means that this section here is a state change. Maybe I can just name it AB, and this can be another state change CD. So according to what the information says, that if you use an impure substance, so if you note the temperature of the impure substance, the boiling point is going to be even larger than 100 degrees Celsius if it is water. So the temperature can be somewhere over here. Say, I'm just drawing a very hypothetical diagram, not to scale, so please excuse. So suppose it is 102 degrees Celsius. So this could have been my new boiling point, And what happens to the melting point then? So the boiling point, of course, we know goes higher if there's an impurity present, and the melting point is decreased by impurities. So the ice will not melt at 0 degrees but will melt at a lower temperature. That means how will the graph look like? Okay, the melting point will now look something like this. It will be even lower than this. So the new graph, if at all you've been asked to draw in the exam, will look something like this. Okay, so what happens to the melting point? It goes even lower. So what's lower goes even lower, and what's high up already goes even more higher. So one more thing you need to know about the melting and the boiling points is, if you have a large number of impurities, then the melting point will go lower and lower. So depending upon the amount of impurity, if the impurity is in a large quantity, the melting point will be a lot lower, and if the impurity is again in a large quantity, like I said, the boiling point also will be higher. So the amount of impurity decides how high or how low the boiling and the melting points are going to be. Fine. So this was all about purity in today's video. Like I said, please visit our website smartexamresources.com to gain access to free study material for chemistry and videos. So well, that's all in today's video, and if you like watching my video, please do subscribe to my channel. Thank you.